I needed to make a video this weekend, and I also wanted to go backpacking. So I'm gonna do both. I'm on top of San Bernardino Peak, and it was 8 miles up here. We're at 10,600 feet or something like that. And I would have started this video way sooner, but I was basically out of breath like the entire time. So we're gonna hike 2 miles back down to camp and try to get some water out of a frozen river. And while we do that, we're gonna learn about counting. Oh man, I'm exhausted. Let's go. Before the light goes down, let's start with something basic and think about my sleep system. So when you go backpacking, you typically have 3 things. A mat that just goes on the ground, an air mattress that inflates, and then a sleeping bag. I have 2 options for the mat. I've got 2 options for the air mattress, and then I have 3 sleeping bag options, and I just pick those depending on the weather. Definitely glad I brought the 0-degree bag for this trip. It's a little chilly. So that's 2 times 2 times 3. 12 different ways that I could put together a sleep system for a camping trip. So that's the basic counting principle. You just take the number of options for each element of your decision and you multiply those numbers together. So let's think about a different example. There's a bunch of really great mountains to hike in Southern California. You've got San Gorgonio, which you could see from this, which is San Bernardino Peak. You got Ontario, Cucamonga, Etowanda, never done that one. But for simplicity's sake, let's just say there's 5 peaks that I want to hike this year. I want to do 1 a month, and I'm starting to plan which hike I'm going to do each month. In January, I have 5 choices. February, I don't want to repeat any of those, so I only have 4 choices. March, 3. April, down to 2 choices. And then in May, I have 1 choice left. 5 times 4 times 3 times 2 times 1. That means there's 120 different ways I can organize my hikes for the year. Okay, so 120 different hikes. That seems insane, right? There's only 5 mountains. How can there be 120 different hikes I can go on? The reason it's so many is because order matters. I could have A, B, C, D, E, and then I could have B, A, C, D, E. You see what I'm saying? Okay, now you might have noticed a button on your calculator before that is an exclamation point. You might have used it to write notes to your friends. But maybe that's just something we did in 2008. I mean, texting was a thing, but I definitely wrote notes to my friends on my calculator and then passed it to them in calculus. I was pretty cool. I was a pretty cool kid, if you didn't already know that. That exclamation point is called a factorial, and 5 factorial is what we just talked about. 5 times 4 times 3 times 2 times 1. Okay, so let's say I'm only going to go on 2 hikes to start the year. I still have 5 choices, but I'm only picking 2 of them. I have 5 choices for the first hike. I have 4 choices for the second hike, and then I'm not making any more choices. Okay, there's no 3, 2, 1. So that's 5 times 4 is 20. So if I'm only picking 2 out of the 5 mountains, there's only 20 different ways I can put together a hiking schedule. So those 20 ways of doing 2 hikes, that's called a permutation. The way we got it was by taking 5 times 4 times 3 times 2 times 1, but then taking away the 3 times 2 times 1. Simplified, that's like 5 factorial over 3 factorial. So it's like, if the number of options is n, that'd be like n factorial on the top. And then on the bottom, let's say like r is the number of things you're actually picking. It'd be n minus r factorial on the bottom. Because if you're picking 2, you've got to get rid of the other 3 in the factorial. Editing me will make that make sense. A little bit rocky here. Don't do too much math while you're walking on the rocks. You gotta watch your step. So the 20 different ways I could arrange my hiking schedule, that's called a permutation. Permutations are when you choose a certain number of options and the order of the options matters. You'll notice that hiking mountain A and then mountain B is different than hiking mountain B, mountain A. And in reality, there probably is a reason that you might want to do one hike first. You probably don't want to start with like the highest mountain that exists. You probably want to train to get to that mountain. But let's think about if we didn't care about order, what would happen to this list? So if order doesn't matter, we can just take away all the duplicates, like AB and BA, we can just take away the BA. That's going to get rid of half of these. So if order matters, there's 20 different ways we can arrange the hikes. If order doesn't matter, there's only 10 ways. Okay, jumping in with a voiceover here because I think the altitude was getting to me and my explanation did not super make sense. Remember earlier I said N was the number of options and R is the number of things that you are picking. In this scenario, there are 5 options and we are picking 2 of them. To calculate the number of permutations where order matters, you do n factorial over n minus r factorial. And in this example, that gave us 20 permutations. 20 different ways of doing the hikes where order does matter. To find the number of combinations where order doesn't matter, you take what you got for the permutations, in this case 20, and you divide by r factorial. And remember, r is the number of things that you're picking. So in this case, 2 factorial, which is just 2 times 1. So if we were picking 3 hikes instead of just 2, for the permutation it would be 5 factorial, and this time it would be over 2 factorial, and that would give us 60 hikes. Remember, that's where order matters. But if we want to pick 3 hikes where order doesn't matter, we would take that 60 and we would divide by 3 factorial because we are picking 3 hikes. So just quick recap, here are your equations for permutations and combinations. Depending on the type of calculator you have, you can probably just do these on a calculator. Okay, so here's how you can keep combinations and permutations straight. You know when you open a locker, it's called a combination lock, right? But the order of those numbers matters. So those should be called permutation locks. And I think it's not too late for us to change that. So I would like everyone who watches this video to start referring to those as permutation locks. Instead of saying, hey, what's the combo to your locker? You can say, hey, what's the perm? I don't know. Second thought, I think that's kind of stupid. Oh, it's much easier to go downhill than uphill, I tell you. I mean, come on. That's pretty great. Excuse me, sir? Sir. Oh my God.